This lab is the chromatography of food dyes. Chromatography is a method of moving pieces of a mixture or a pure substance up a substrate so that we can see certain characteristics about it. We're going to analyze food dyes. We know that different substances are soluble in different solvents. We're going to pick an eluting solvent, a solvent where some things are more soluble in than others. We're going to have a substance. This is the thing we're trying to figure out about. It's going to be placed on, in this case, a piece of paper, a substrate. There's other substrates we can use. You can do gas chromatography, you can do thin layer chromatography. We're doing paper chromatography. We're going to place that spot onto a piece of paper. We're going to put that paper so that the bottom of it is exposed to an eluting solvent. The eluting solvent is going to travel up the paper. And as it travels up the paper, it's going to attach or be attracted to our substance in some way. Maybe strong, maybe not strong. Our substance is also attracted to the substrate, the paper behind it. So as the eluting solvent travels up the paper, the substance is being held onto by the paper, being held still, and being dragged up the paper by the solvent. The more attracted it is to the solvent, the more it's going to move up, and the faster it's going to move up the paper. The less it's attracted to the solvent, the more it's going to be held onto the paper and not travel as much. Different substances will travel different amounts. In this experiment, what we're going to do is we're going to take 6 food colors, and we're going to analyze how far they travel, how soluble they are in the solvent. If it's more soluble in the solvent, it will travel further up the paper. If it's less soluble in the solvent, it will travel not so far. We will then have our 6 knowns with our eluting solvent, and we'll have an unknown. We will try and identify the identity of our unknown by comparing it to the results of our knowns. That is very simply paper chromatography. Now let's talk about the specific procedure. You're going to take a piece of paper. It's a rectangle. On the bottom of the piece of paper, you're going to draw a line. Whenever you draw something on the chromatography paper, we need to draw it in pencil. If you draw it in pen, the eluting solvent will make it travel as well. Pencil will not be attracted to the solvent at all and will always stay there. We don't want our pen, if you were to use a pen, which you're not going to use, we don't want the pen traveling up the paper with our substances. So we're going to draw a line in pencil, and then we're going to separate our line into 7 pieces. You're going to put the 6 knowns and then the unknown as a spot on the line to be analyzed. Now, when I say put it on the line, you're going to take a toothpick to move the substance. So you're going to have a sample of your food dye. You're going to take a toothpick, you're going to take a tiny spot of it and place it, as described in the procedure, on the line. We're then going to let it dry. Then you're going to place another spot on top. We want to be sure that we're kind of building a mountain of our substance, not letting it spread out in a wide base. We want it to be small but tall. We're going to do this for each of our substances. We are then going to, once our paper is spotted, we're going to staple it into a cylinder and put this into our Petri dish. But before you put it in the Petri dish, we have to put the solvent in. So we're going to put the solvent in the Petri dish, but we do not want the solvent touching any of our spots. If they touch our spots in the Petri dish, it's all going to run out into the Petri dish and contaminate our entire experiment. So you want to make sure our eluting solvent is below the level of all the dots, which are on that line we drew. We're then going to let it sit. We're going to let the solvent travel up the paper. And as it travels up the paper, it's going to carry these substances, maybe a little bit, maybe a lot, maybe not at all if it's not soluble at all in this thing. And we're going to stop it when the solvent gets about 2 centimeters from the top. If we were to let it keep running all the way to the top, it would carry all the spots and keep carrying even the slow ones as the solvent keeps traveling up and would ruin our results because all our substance spots would end up at the top of our chromatography paper. So we're going to stop that about 2 centimeters from the top. We're then going to take a pencil and draw a line across the top that indicates our solvent front. Our solvent, which in this case is salt water, is simply going to evaporate. And once it evaporates, we won't know how far it traveled. So we need to draw a line in pencil as soon as you take it out of the solvent. We are then going to quantify our results with something called an RF factor, or a retention factor. The retention factor is very simply a ratio of the distance the spot traveled. We're going to take a ruler and measure where it is from that first line where we spotted it up until the point where it ends at the end of the paper chromatography run. We're going to take the distance the spot traveled divided by the distance the solvent traveled. This will always be 1.0 or less. You need to measure very precisely with your ruler. Why is it always less? Because the spot cannot travel further than the solvent. The denominator, the distance the solvent traveled, will always be greater than or equal to the distance the substance traveled. The RF factor then is a characteristic of that substance in this solvent. We then compare our unknown. We can see how far it went. We can calculate its RF value. And if we can identify it, its RF value is going to be the same as one of our known substances. It's also going to look the same visually. The colors may look different once they've eluted. If it's a mixture, we may have more than one piece of it, and we may end up with two spots in a run. Our unknown will match one of these, both in RF value and what it looks like. Our goal in this lab is to identify what is the identity of the unknown. Chromatography is used a lot to identify unknowns, but you must have a known substance to compare the unknowns to identify or to find their identity. Again, in this lab, we're going to identify we're going to try and figure out what the unknown is by comparing it to our 6 known. Our unknown might also be a mixture. The unknown might contain 2 of the knowns. And you'll be able to identify that. It may then form more than one spot and may have more than one RF value. There's an RF value for each spot.